Hello everyone. Let us today understand what is circularly polarized light and elliptically polarized light. You already know what is plane polarized light. A light whose direction of vibration of the electric field is restricted to only one direction is called plane polarized light. For example, these two. These two are two plane polarized light whose direction of vibration of electric field are mutually at right angles. This plane polarized light is having vibration along this direction, and this second one is having the direction of vibration at right angles to this one, like this. Okay, and both the vibrations are perpendicular to the direction of propagation. Okay, and when these two vibrations will superpose, then we will have a number of different cases. Sometimes the superposition of these two vibrations will give us again plane polarized light, and sometimes it will create circularly polarized light and sometimes elliptically polarized light. So let us understand that from the mathematical derivation. We consider that the two plane polarized light, they are represented by these two equations. Ex equals to a cos of omega t plus phi and uy equals to b cos of omega t. That means that their amplitudes are different, a and b. The frequencies are same, omega, angular frequency, and they are along two perpendicular directions. This is along x direction, suppose, and this is in the y direction. Okay. They are at right angles to each other. So let us see that what are the conditions that we will get by superposition of these two plane polarized light. Okay, so for simplicity purpose, instead of writing them as Ex, Ey, we can just write them as x and y. Okay, so we are taking this simpler form. X equals to a cos of omega t plus phi, y equals to b cos of omega t. Now, just from these equations, we can derive one equation, one common equation for both of them. Take the first one, write what is x by a is equals to cos omega t cos phi minus sin omega t sin phi when you expand the right hand side. Then from the second equation, cos omega t equals to y by b minus sin omega t will be 1 minus y square by b square. Then x by a minus y by b cos phi will be equals to minus 1 minus y square by b square sin square phi. Then if you square both of them, we will be getting x square by a square minus twice xy by ab cos phi, right? Then y square plus y square by b square cos square phi, and on the right hand side this square it will go 1 minus y square by b square sin square phi. So here if you combine this term and this term and bring it to the left hand side, so it will be x square plus y square by b square. Because it is common, y square by b square common, within bracket cos square phi plus sin square phi will give you 1 minus twice xy by ab cos phi is equals to sin square phi. Call it equation number 1. Okay, so this is the equation which gives us the status of the superposition of the two vibrations. Okay, so it will tell you that what will be the resultant due to the superposition of these two perpendicular plane polarized light. Alright. So now let us understand for different values of the phase difference phi what we will get. So first let us consider the case when the phase difference is 0. What does it mean? Phase difference 0 means if the first one is starting like this at time t equals to 0 it has started. The second one will also be starting at the same moment, t equals to 0. This is the meaning of phi equals to 0. Okay, so for phi equals to 0, what will the equation 1 become? X square by a square plus y square by b square minus cos 0 will be 1, so 2xy by ab is equal to sin 0 is 0, so that it will be x by a minus y by b whole square equal to 0, or x by a minus y by b equals to 0, or x by a equals to y by b, or y equals to b by a into x. This is equation of straight line. That means that the result will be, if phi equals to 0, the resultant will be a plane polarized light again. It satisfies the equation of a straight line. So the resultant electric vector Ex and Ey, they are superposing. So resultant of these two is, suppose we call it E, right? So the tip of this resultant vector will follow a straight line path like this. Okay, this you can also understand from the idea of Lesage's figure in sound. In simple harmonic motion, what you have, similar kind of thing, right? You have two simple harmonic motions superposed. If this condition is satisfied, so it will be a situation like this, right? And here, in this case, for light, it is the plane polarized light. The resultant light vector will be plane polarized. What does it mean? The resultant of Ex and Ey is, suppose, E, and that resultant electric vector will follow this path, linear path. Okay, this is again plane polarized. Now come to another case, case number 2, suppose. Okay, second case, we say that the phase difference between the two vectors Ex and Ey is, suppose, phi equals to pi. Means x square by y square plus y square by b square will become what? Cos pi is minus 1. So it will be, and sin pi is 0 again. So this time x by a plus y by b whole square will be equals to 0, and this time also x by a will be equals to minus y by b, or y equal to b by a, x with a minus sign. So that means if the phase difference is pi, then again it is an equation of straight line, but the slope is negative, right? Y equals to minus b by a x. That means the slope is negative. Here the earlier case for phi equals to 0, the slope was positive, right? We had y equals to b by a into x. Here it is negative with a minus, right? So this is again a plane polarized line, right? Now let us come to the third case, when the phase difference is 90 degree. When the phase difference is 90 degree, then equation 1 will be reducing to this form, into cos of pi by 2 is 0 and sin of pi by 2 1. So x square by a square plus y square by b square equal to 1, which is equation of an ellipse, and therefore the tip of the resultant vector of Ex and Ey, we call it E vector. This will follow one elliptical path, and the light will be called elliptically polarized light. And if in addition to this If also A is equal to B, then x square plus y square will become equal to A square, which is equation of circle. That means under that condition the light will be circularly polarized and E vector will follow a circular path. The tip of the E vector will follow circular path. Okay, so this is how elliptically polarized light and circularly polarized light are obtained from superposition of two plane polarized light at right angles to each other. So let us now come to the summary of today's class. If we have two plane polarized light superposing with each other at right angles to with each other, then the resultant light vector may be plane polarized, circularly polarized, or elliptically polarized, depending on their initial phase difference. Okay, so that's all for today. Thank you.